Hello, everyone. Let's solve this problem LeetCode349 intersection of two array. Okay. So we actually just talked about it in the previous videos, and then we can use brute force algorithm. We just talked about it. If you are interested, you can check my previous videos, and also hash set. Okay, and then we do the sort and the binary search. So the first step, we're gonna compare the numbers 1 and the numbers 2, find the smaller one as numbers 1, and then we sort the numbers 1, and then we iterate numbers 2 to check if the numbers 1 set contains numbers 2, and then we include the shared atom into intersection. This is basically the algorithm we just did in the previous video. And then now we are going to talk about the sort with two pointer for this problem. Let's still use this example. So what we do here, so what we do here, we have a two pointer here is I, and here is J. So what do we do? So first, what we do, we new a set is a hash set, and then we sort the numbers 1. We sort the numbers 1 first, and then we sort the numbers 2. So after sorting, here is gonna be 1 second. After sorting, here is gonna be 5, 9. And then this one gonna be 4, 4, 8, 9, 9. Okay, 4, 4, 8, 9, 9. Okay, so after sort, will be like this. And then what we do, we just have a while loop. We check if the numbers 1i here, I equals to 0, j equals to 0. So if the 4 is smaller than the numbers 2, no, it's not, it's equal. So, and then we put it in the set. Okay, we have something, it's a hash set. We call it set. Okay, we put the result to the set. We can do it intersection or whatever, right? So we can call it intersection actually. Let's intersections. Okay, so here is 4. Okay, and then I plus plus j plus plus. So we will compare the 5 smaller than the 4. No, this one is smaller, so we j plus plus, and then we compare 5 smaller than 8. Yes, then we I plus plus, the j we are not plus plus, and then we check a 9 smaller than the 8. No, then we j plus plus, and then we check the 9 is greater is equals to 9 right here, and then we put this result in the intersections, and then we do j plus plus, we do I plus plus. Okay, we do j plus plus, and then after j plus plus, but I already kind of like out of the boundary, so our while loop is stopped. So this is basically the algorithm. Let's start coding for the algorithm. So for this problem, what we do here, first we will check the numbers 1 equals to none, and the numbers 2 equals to none. Okay. Oh, sorry about that. Okay, what we do, we return none. Okay, this is the corner case, and then what we do the set inter o. and then we sort it. So we sort the numbers 1, and then we sort numbers 2. And then after we sort the initial integer I, integer j equals to 0. And then what we do here, we have a while loop. We will check if I smaller than numbers 1 dot length, okay, and j smaller than numbers 2 dot length, okay. And then if this one, then we will check if the numbers 1, if the numbers 1 smaller than the numbers 2, if it's smaller than the numbers 2, so what we do, oh no, here is j, numbers 2j, if this element is smaller than that one, so what we do, no, here is a, okay, so what do? We add plus plus, okay, we add plus plus, else if numbers 1 I greater than the, if this one greater than the numbers 2, if greater than that one, so what do? We j plus plus, else is like numbers 1 equals to numbers j. So in this way, we're going to put intersections. We put the result to the intersections. Numbers 1, I. Here, actually, we also can put numbers 2j. Okay, that's the same thing because it's two atom the same. And then we I plus plus, j plus plus. Okay, this basically we're doing. Let's run the code. Oh, we need to return. Sorry about that. We still need to return. We are okay. So we return intersections dot string. Okay, map to int. Okay, inside here, what we can do as minus s dot to array. Okay, this is basically the result. Yeah, let's run the code. Cannot find this. Let's do this. Oh, sorry, here is wrong. Variable I is already defined in algorithm. Here, intersections, this one. Okay, let's just, yeah. We already defined here, so here we do S. Because we here initialize I equals to 0. Okay, it's accept. Okay, let's talk about the time complexity for this problem. The time complexity for this problem is gonna be O n log n, because we O n log n plus m log m plus m and n. So let's say, let's check here. So because we do have a sort numbers 1, right? So the time complexity for this part is gonna be n log n, and this part is m log m, and then we iterate all the elements from from numbers 1, I, and numbers 2. So that's why our time complexity here is m plus n. So the total time complexity for this algorithm gonna be n log n plus m log m plus m plus n. Okay, so the space complexity for this problem is O(n), is big O1. Sorry about that, because we don't have any extra space. So let's pay attention about here. Here is intersection is a hash set. That's take actually some space, but this one we are trying to store the result. It's not about the algorithm. We are talking about extra space from this problem, so it's O1. Okay, let's submit the code. This two-pointer with a sorting algorithm with two-pointer. So for this problem, we have different algorithm. We can use the brute force algorithm. We can use the hash set algorithm. We can use the sort plus binary search algorithm. We also can use the sort plus two-pointer algorithm. This is the videos we just did. So I already have some previous videos talking about the sort plus binary search, talking about the hash set. If you are interested, you can just go check my channel, and I have other solutions too. I like it. This solution, the sort plus binary search and the sort plus two-pointer. Okay, so because the space complexity is O1, the time complexity similar, right here, very similar. Okay, so but the set is also good, but we used extra space for this one, not the optimum solution for this problem. So our result is faster than 30% of Java online submission. Okay, it's not that bad. Okay, okay. Thank you for watching, and see you next time.